Scientists have always been intrigued about the cosmos and looking beyond the planet Earth. They have sent probes and telescopes to better understand what's happening in the void. Some of the most famous space observatories include the Hubble Space Telescope, the Chandra X-ray Observatory, the Spitzer Space Telescope, and the Voyager 1 and 2. Recently, NASA launched an advanced version of the Hubble Space Telescope into space on December 25, 2021, from ESA's launch site at Kourou in French Guiana. It is the largest and most powerful space telescope to date and is called the James Webb Telescope. While many resources and hopes are linked with the journey of the James Webb Telescope, there is a lingering question. Is this space observatory worth all the financial and astronomical risk? What is the downside to the most advanced telescope launched into space to study stars, planets, and things we don't know about? Join us today as we dive deeper into the problems with the James Webb Telescope and discover what to expect from the giant observatory. It took just 30 days for the James Webb Space Telescope to travel nearly 1 million miles to its permanent home, Lagrange Point 2, a gravitationally stable location in space. The telescope arrived at L2, the second Sun-Earth Lagrange point, on Jan 24, 2022. L2 is a spot in space near Earth that lies opposite the Sun. This orbit will allow the telescope to stay in line with Earth as it orbits the Sun. It has been a popular spot for several other space telescopes, including the Herschel Space Telescope and the Planck Space Observatory. According to NASA, the purpose of the James Webb Space Telescope is to focus on 4 main areas. First light in the universe, the assembly of galaxies in early universe, the birth of stars, protoplanetary systems and planets, including the origins of life. The James Webb Space Telescope is described to probe the cosmos to uncover the history of the universe from the Big Bang to exoplanet formation and beyond. It is one of NASA's great observatories, huge space instruments that include the likes of the Hubble Space Telescope that peer deep into the cosmos. But recently, one of the James Webb Space Telescope's instruments has run into a technical glitch. The next generation telescope has been running fast and furious, sending back stunning scientific observations of exoplanets, galaxies, and even our local planets. The anomaly is a speed bump in Webb's work, knocking out one specific observation mode. The Mid-Infrared Instrument, or MIRI, is equipped with a camera and a spectrograph designed to look at the universe in specific infrared wavelengths we humans can't see. MIRI is skilled at gazing into star-forming regions of galaxies and uses 4 observing modes. On August 24th, a mechanism that supports one of these modes, known as medium-resolution spectroscopy, exhibits what appears to be increased fiction during setup for a scientific observation, as told by NASA. The mechanism that encountered the problem is used to select between different wavelengths when Webb is making observations in MRS mode. The telescope team convened a review board on September 6 to investigate the issue and work out how to move forward. NASA emphasizes that the telescope is healthy and that MIRI's other 3 observing modes operate normally. Webb had already weathered a previous incident when a micrometeorite smacked into one of its mirrors. Micrometeoroids are a known danger of space operations, and facing them is no longer new to scientists. The International Space Station and the Hubble Space Telescope are long-running programs that are still operational despite occasional space rock strikes. However, Webb's orbit at Lagrange Point 2, about 1 million miles from the Earth, considerably changes the risk profile. Webb engineers first detected deformations on the primary mirror during the commissioning period during the alignment, which put the 18 segments of the hexagonal mirror into the best position to capture light. The report stated that these first 6 strikes met pre-launch expectations of the rate, as they came in at a rate of once per month. Moreover, some of the resulting deformations are correctable through mirror realignments. But the magnitude of one of these 6 strikes causes more concern, as it causes a significant blemish to a segment known as C3. The strike in late May caused a significant uncorrectable change in the overall figure of that segment. In this case, however, the overall impact on the mission is small because only a tiny portion of the telescope area was affected. 17 mirror segments remain unblemished, and engineers were able to realign Webb's segments to account for most of the damage, but scientists are scared that such events can damage an investment of $10 billion before it had served its purpose. There has been a lot of debate on whether the $10 billion price tag for the world's most expensive telescope is worth it. The first set of images captured by the James Webb Space Telescope revealed the birth and death of stars and merging galaxies in stunning full color. Direct comparisons of the same objectives taken by the aging Hubble Space Telescope show how much better the James Webb Space Telescope is at infrared wavelengths, with countless more dazzling stars and galaxies popping into view. The James Webb effort aimed to build an observatory that could receive light from the deepest voids of space so scientists could peer back to a time when the first galaxies began to form. But the scope underwent multiple redesigns since work started in the 1990s. It suffered numerous delays with valuable time spent fixing tears in its tennis court-sized sun shield and patching up hundreds of other points of potential failure. Work also had to be temporarily halted when space agencies ordered employees to stay at home during the onset of the coronavirus pandemic. And remember that the telescope also repeatedly missed its initial launch date due to vibrational issues and a faulty data cable. All the while, costs for the telescope continued piling up. It finally blasted off from Earth at the end of December, arriving at its home a million miles away a month later, and detected its first photons in February. Now it beamed back photos of, among other things, galaxies as old as 13 billion years. And so after a quarter of a century or thereabouts of work and a hefty $10 billion bill, what does the entire effort have to show? Not only is the James Webb Telescope providing humanity with the widest, deepest, and most precise view of the universe, yet it is operating at a level that has exceeded expectations. According to a 60-page report from NASA, ESA, and the Canadian Space Agency, the telescope's scientific performance is better than scientists hoped. The optics are better aligned, the point spread function is sharper with higher encircled energy, and the optical performance is more time-stable than the requirements. The fine guidance system points to the observatory several times more accurately and precisely than required. The mirrors are cleaner than requirements, which translates to lower than expected levels of near-infrared strain light, meaning that the sky background will be darker for JWST than expected. The science instruments have generally higher total system throughput than pre-launch expectations. These improvements mean the James Webb Telescope has a wide range of capabilities, including the potential to peer at different types of objects, from nebula, galaxies with quasars, the hubbub of stars, toward the center of the Milky Way, our solar system, and near-Earth asteroids. Scientists have directed the telescope to take infrared images of Jupiter and its moon, and have collected spectra from 8 space rocks. While a lot is on the line and all eyes are on this traveler of outer worlds, the James Webb Telescope has been doing well. It has made some fascinating discoveries, like the collection of 5 galaxies, Jupiter and its moon, and tracking asteroids for the first time. There is a lot to cover in the universe, and scientists hope the telescope will function for a couple of years to help them understand the universe better. Do you think the $10 billion investment in James Webb Telescope is worth it? Will the Space Observatory work without fault and keep sending data back to Earth? Tell us what you think below.